Exponential equations. An exponential equation contains a variable and one of its exponents. So we have an equation like this, where the x is in the exponent and a variable is in the exponent. That is an exponential equation. In order to solve these, we have the exponent property of equality. If we have two exponential expressions with the same base that are equal, then their exponents are equal. For example, b to the x equals b to the y is equivalent to x equals y. If you think about that, it makes quite a bit of sense. If the left side really does equal the right side, and the bases are the same, then it forces the exponents to be equal. So let's see if we could try this on this problem. It doesn't look like I have the same bases, but I could equate the bases. I could express 9 as 3 squared. After that, I use the property of equality on exponents, and I find that x is 4. You can check that as well. 4 minus 2 is 2. 3 to the 2 is 9. It's not a mandatory check, but just to show you how that works. Pretty handy. So let's do some practice problems here. Solve the exponential equation. Our bases are the same, so we know that the exponents must be equal. Then we solve that. Here, our bases are not the same, but we can write 8 as the base of 2. So it's 2 to the x minus 2 equals 2 cubed. Now that my bases are equal, I can equate my exponents, getting x minus 2 equals 3. Solving that, I get x equals 5. Here I have 5 to the 2x equals 1 over 25. You might recognize that 25 is a power of 5. It's 5 squared. So what causes it to be a fraction of 1 over 25? What causes that is when we have a negative exponent. So if I had 5 to the negative 2, that's 1 over 5 squared, which is 1 over 25. So these really do have common bases. We just need to rewrite them. 5 to the 2x is 5 to the negative 2. Then my exponents are equal, and my x is negative 1. Now this one's a little interesting problem here. I have a 2 to the 3x and an 8 to the negative x plus 2. Of course, 8 is 2 cubed. So let's see what happens here. I'm going to replace 8 with 2 cubed, but it already has an exponent on it of negative x plus 2. So if you remember, if you have a base with an exponent and that's raised again to another exponent, then those exponents are multiplied. So this is 2 to the 3x equals 2 to the negative 3x plus 6. Remember to distribute that 3 throughout the negative x plus 2. Now my bases are equal, so my exponents are equal. 3x equals negative 3x plus 6. 6x is 6, and x is 1. Here I have 5 and 25 as my bases, so I'm going to rewrite my 25 as a 5 squared. 5 to the 3x squared minus 4x equals 5 squared, and then that was to the second power. So we have 5 to the 3x squared minus 4x equals 5 to the 4th. So now that my bases are equal, I can equate my exponents. 3x squared minus 4x equals 4. 3x squared minus 4x minus 4 equals 0. Remember, this is a quadratic equation now, so we're going to have to get it all on one side equal to 0 and try to factor it. So I'm going to have a 2 and a 2. I'm going to do a negative here and a positive there. That will give me a negative 6 plus 2x is a negative 4x. So 3x plus 2 equals 0. X minus 2 equals 0. 3x is negative 2 and x is negative 2/3. Over here, x is 2. So we end up with 2 answers here. That's all, and you can go ahead and start on your homework over this section.